Hi everyone, I'm Nathakan Owawaskun. My student ID is 224205628. Today I present my analysis on predicting the quality of red wine based on chemical characteristics. Here is my presentation overview. Firstly, I'll be exploring a dataset. Dataset contains a lot of property. Firstly is acetic acid, chloride, total sulfur dioxide, pH, and alcohol level. This characteristic can predict the quality. According to histogram, it showed that most variable are like right skew, so it means low value feel high extreme. But the data distribution of pH is approximately normal distribution. And for the quality distribution, most wine is descend to good quality is allowed 5 or 6. Now before we do the data transformation, we need to adjust the outlier. So as you can see, there's a lot of outlier in the chloride variable and total sulfur dioxide. To handle outlier, I choose the visualization method instead of removing outlier because to avoid the lost data. The concept of visualization is replacing extreme value with the less extreme one. So this is the process of this method. As you can see, there is no outlier in my sample. Now we can focus on the data transformation. I selected the 4 variables which are acetic acid, chloride, total sulfur dioxide, and alcohol. Then I apply power transformations and log transformation to variable. So because of my data distribution is right skew, so I use p-value less than 1. And then I using the z-score standardization. So how can I choose the data transformation method? I use the skewness and case test. I compare between before and after transformation. My aim is to bring the skewness closer to 0 and minimize case test. So as you can see, my data distribution are more normal distribution. Now let's discuss the importance of each selected variable. So I use the heat map and correlation coefficient. So the result is citric acid is moderate positive correlation with quality. Chloride is very weak or no correlation. Total sulfur dioxide is a weak negative correlation, and the last one is alcohol is strong positive correlation with quality. And now next we gonna shoot the best fitting model. So we explore several aggregation function to predict wine quality. So based on RMSE, the power mean with p equal 0.5 is the best fitting model because it's lower RMSE. And this is the weight of each variable. As you can see, the alcohol is a strong influence on quality. Now we're gonna use the best model to predict data. This is our new input, and then do the data transformation and standardization. Use the model and inverse function for quality. And my predicted quality is 2. So I think it seems reasonable considering in the relatively low alcohol content, which we know is not like key driver of quality. we're gonna talk about what is the best condition of red wine. Based on my analysis, a higher quality red wine is likely to have a higher alcohol and higher citric acid. But the higher quality of red wine is a lower sulfur dioxide level. But for the chloride is not a major factor within the tip current. Now we're gonna talk about implications. First, predictive accuracy. So we use the power mean with p equal 0.5 to robust against outlier is assigned weight to a variable based on their importance. And the second one is handling skill data. So we use data transformation like power and logarithm chains and use the z-score normalization to ensure all variables are on the same scale. And the last one is limitation. So the first one is limited scope. So we have only like citric acid, chloride, total sulfur dioxide, and alcohol to predict the quality. And the second one is depend on the data transformation. So if we're not good at data transformation, so it maybe lead to the wrong prediction. And the third one is generalization to new data. So the model is based on transform and normalized data. If is new data isn't transformed the same way, so the prediction is might be unreliable. Here is my reference, and thank you.